Hello and welcome to Differential Discussions. I'm Melissa,
And I'm Dave.
and we're back with another Serous fluid.
Yummy. Yummy is probably not the right, but
Yummy's great.
you get those plural fluids that have like the big gelatinous blob clots in them.
Yes. Yeah.
Yeah, I think it was Steve that told me that plural fluid has a lot of tissue factor in it. And that kind of makes sense, right? Like you see these like clots forming. Also makes sense because like, hey, it's the lungs, right? The lungs are important.
Mm-hmm.
End of video. All right, I'll stop being silly.
Well, let me scan.
Yep. So we're being diligent microscopists on low power, looking around. Cool. I see some colorful big stuff.
Not liking that already.
Yeah, I know. I'm always like hesitant to just do too much description stuff at low power like this, but yeah, that nucleus looked like it had like a hole in it, so it's not good.
Another dark blob.
So yeah, maybe one might ask, well, what are you looking for on low power? But some of those dark blobs, that's kind of the kind of stuff that we're looking for. It's like easy enough when you're scanning at a high power to kind of as you're scanning through to like miss a field or two, right? Whereas if you scan on low power, some of the larger, more in your face findings, it also kind of helps you direct your attention.
I think I'll drop down here.
Sounds good to me. Yeah. So really pretty. I like the that dark blue like kind of ring. A little bit weird. So
Look, there's a plasma cell.
wow, beautiful. Good eye. Very good eye. I'm more
Let
excited
me
about that than these lungs.
let me let me drop down so we can see them closer.
Sounds good.
Ah,
You get it. Well, that's a window. So
that is a window.
so when we talk about mesothelial cells or tissue cells, there's usually what we call a window between them, so you can see. It's usually much smaller than that. So yeah, this is the equivalent of like that giant picture window on like a mansion. This is ridiculous. Um, so yeah, that particular area there is a window we're referencing, and they're usually significantly narrower. So then I'm looking at these nuclei, and I don't like the kind of lumpy, bumpy kind of ridges and stuff on those nuclei. This one, it's got some kind of a fold here. That could be normal because it could be two nuclei, and a meso could have two nuclei, but I'm still generally troubled by it, especially that cell on the left.
Mm. And they seem almost bigger
They
than
do.
what I expect from
Yeah,
mesos.
I think that's very true. So yeah, luckily we have monos in the field too to kind of and red cells to kind of ground our expectations of size.
Let me see if I can find that plasma.
I know. It's tough.
Hey, hey, hey.
Hey, perfect.
That's
Right.
like a
Chef's kiss plasma cell. So I've when I instruct, right, it's an eccentric nucleus. Nucleus is off to the side, deeply basophilic cytoplasm with a perinuclear halo, and check, 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 right? Nucleus chromatin pattern is exactly what I might expect to. You tend to have these like areas of like that. Oh, man, I cannot draw today. Not that I can draw other days, but you get those areas of like the deep, like dark clumped chromatin, and
Right here.
yep. So
With the really prominent white striations, and
exactly.
they're very
Yep.
prominent.
Yep. This is just very good. Perfect.
The
Plasma.
perinuclear Hoff is gorgeous.
It is very good.
All right,
Yeah.
I just wanted to look at him. Now we can keep going.
Yeah, yeah, no, it's good. And so we see a cell reacting, right? And so we can have plasma cells in types of infections, a viral infection, bacterial infection, and you can also see them in malignancies. So,
yep.
And I think, hint, hint, wink, wink, those those slums we saw in the beginning looked a bit troubling for malignancy.
Yeah, and then we just got a couple of macrophages,
Agreed.
some lymphies in here.
Yep, agreed.
What else we can find? More macrophages and lymphs. Lots of big fluffy macrophages.
Yeah, and geez,
Ooh,
this particular cell too is
look at these.
oh, beautiful. So mesothelial cells, it's just terrible. Terrible.
Yeah.
This is beautiful. I love, so like if it weren't for it probably being cancer, it's not a bad like reactive meso sort of picture. So in inflammatory conditions, the mesothelials can have this like deep basophilic kind of coloration, but you still get that fried egg sort of pattern that's kind of characteristic, and that helps me differentiate it from maybe like huge plasma cells or things of that nature. But yeah, I would lum this all day.
Yeah, I think it's not a meso because it like the nucleus is really dark and ugly and
Yeah.
doesn't look nice and normal. And then the cytoplasm, it does have that fried egg appearance, but it's almost like you overcooked the egg.
Yeah. Yeah. So yeah, a couple of alums in this field, I would say. 1 and 2. Don't like you.
Do I don't like you. That's cute.
Dr. Susan over here. Again, I mean, these aren't like the worst lums I've seen, but I don't like these bumps. They shouldn't be there.
Agreed. And then there's these guys over.
You know, and it just kind of gets reinforced. So I sympathize doing body fluids. You might see a cell or two here or there across like 100, 200 cells, and you might agonize, but we're seeing these cells kind of repeat, right? They're not necessarily dominant. They're probably 10% or less or whatever, but they're there, and they're just over and over again.
Oogly. Dark.
How do you spell oogly?
Oogly.
I feel like that's O-O. That's O-O-G-L-Y.
Oh, that's a good way.
So, ring nuclei are typically like signs of like bad stuff like MDS and such, right? So this could be, so kind of what's fascinating is like you can have cells like lums or mesos that hang out in a body fluid for so long, they kind of start to look like monos and mags. So I think that's what's going on here. This is probably one of those bad lums that's just getting old in the fluid, lost a lot of its color. Because my instinct is that it's probably not a macrophage.
Probably not. And even if that's not a ring, say that's like a giant nucleoli, that's not normal.
Yeah, yeah, it's a good point. That's a good point, right? If someone were to try to describe that as a nucleoli and you defer on that and say, fine, I'll accept that. But, right, that's just way too big for normal physiology. Yeah, agreed. Yeah, like some, you know, Like we can see a little bit of a, like, look, that's a reasonable
Yeah.
nucleoli, right? That other one is not too big. Come on,
Some of
mom.
these lymphocytes, I think, are starting to like look
Yeah,
a little reactive.
yeah.
Not quite as nice as that gorgeous plasma
Ooh.
cell, but like, look at this guy.
Yeah, absolutely. I agree with you 100%. Get a
So, yeah.
reactive. I
Oh, these are the same two we saw before. Let's keep going.
think so, yeah.
Here we go. No, let's go in the other direction. Sorry. So I think this is nice because, like, he looks like the other malignant T cells that we're looking at, but he's small.
Way small. Yeah.
He's
Yep.
trying to blend in.
He's incognito, right?
What you talking about? I'm not malignant. Look.
This is like the equivalent of like the trench coat and like the glasses, spy versus spy. Yeah. Yeah. I'd still love him.
Yes. Oh, yes. Ooh.
Oh, beautiful. So yeah, I generally expect the nucleus to be a little bit smaller, but geez, it checks all the boxes that I care about though, right? So deeply basophilic, perinuclear halo, eccentric nucleus, plasma cell.
He's gorgeous.
Yeah.
Ooh, and look, we've got a baso.
Oh, pretty. Love it. Beautiful baso. Beautiful baso. And maybe another reactive limb too.
Yes.
Yeah.
Okay.
A little bit of basophilia, a little bit of a perinuclear halo. I would probably say that that's like plasmacytoid and still
Yes.
active lymph.
Ooh, there's an EO.
Hey, they've all joined the party. I don't know if we've seen a neutrophil, but
I don't know that we have either. But we can say this is not a neutrophil
right.
because of the granules. They're significantly larger.
Yeah, agreed. The other dead giveaway too is like EOs a lot of times don't have a full cytoplasm. And so you'll have these areas where you get this like faint sky blue kind of cytoplasm. Good job, EO. Good job not being a lum.
Hey, look, there's a neutrophil. We found one.
Hey! So we have a pretty good cross section of hematopoietic cells here.
Yeah. Another reactive lymph, I'd say.
Yes, agreed. So yeah, definitely things the lymphs aren't happy about these lums. Yeah, and you know, this is probably the best looking one of all of them. And I wouldn't be offended if someone called meso.
Yeah.
But I've already seen lums,
Mhm.
and I would say it's not perfect. So I don't know your thoughts on this though.
I would call him a lum too. I see the mesos thinking more like a reactive meso looking at him because of how blue the edges are, but again, he looks like the other lums that we've
Yeah.
seen. And then if you look at the nucleus, we got this nice big dark spot there.
That's not normal, right?
You
Like
kind of have this light spot over here, which I guess could be the nucleoli, but
so mesos typically are pretty uniform on the chromatin pattern, right? So that's a great point. Yeah, that's a great point. Yeah, sometimes I'll know the category I want to put it in, and it's not entirely easy to articulate. So this is like a good window. So like that's more of like a normal kind of a window to see. So I don't know. What do you think? I'm not offended to call these mesos.
I'm not either.
Yeah.
I was debating in my head, but like I was looking and like I'm not seeing the deep dark or variations in the coloration either in the cytoplasm or in the nucleus.
Yeah.
They
Yeah, because
look
I'm trying to be mindful because like over here it's a little dark, but it's also being kind of smushed. So um, you know what? I'll give you a couple mesos.
yeah, I mean, and they're small in
Yep.
comparison to the lums, which are huge.
Yep.
Most of the lums.
Yep.
And most of the lums that we're seeing do have that really dark blue edge.
Yeah.
And this one does not have that dark blue edge.
The contours of the nucleus are kind of nice and round and smooth. So yeah, a couple healthy mesos.
Hey!
And then reinforces, right? Like this is ugly. Like yeah.
Yeah, so let's just this
Yep. Normal.
versus this.
Not normal.
No.
I picture it's like the oh geez, this is terrible to say. But like these I don't know if I should say this.
Let's not say it then.
I'm gonna do it anyway.
Okay.
The faces of meth. You ever seen the faces of meth? Like this is the faces of meth for they'll show an individual like early in their so they'll have the mugshot and then the next mugshot, and you just see the people.
Yeah. Deteriorating.
Oh goodness. And so that I instantly thought of that
Yeah.
comparison.
Yeah, that's a good comparison. Like if you look here, it does have a window. And the window, it's normal to have a window, but it
It's
doesn't
an
look
ugly
normal.
window. Yeah, it's a really ugly window. And
It's
like
like
that's not in itself the only damning feature, right?
right,
There's so we can just kind of keep going, right?
right.
But
But somebody might look at it and say, well, there's a window.
yeah,
But that's one feature that mesos have. And you got to think about, well, there's a window, yes, but it's not a nice looking window. And then the nuclear contours, the cytoplasm has a similar, uh, where it's kind of darker at the edges and lighter in the center, which is what our other malignant cells have been doing. And it's just the coloration of the nucleus is off. Again, it's just hitting all of the things that malignant cells have. Save the window. Like this has a window, but it's not a normal looking window.
yeah, yeah, especially in comparison. So
Yeah.
yeah, not all the time you're gonna get like the side by side kind of comparisons, right? So
Yeah.
I think it's one of the most difficult
Bring it
part
back
about
up.
differentials in general is you don't necessarily have a template to compare
Yeah.
things with. Yeah.
Especially when you're dealing with malignancy, because
Yeah.
the cells are going to do what they want.
Yes.
Even when you're going patient to patient to patient, the cells can look slightly different. The normal cells can look slightly different.
So true. So true.
Ooh. Oh,
I can't even begin to describe how terrible those are. So yeah. Lum.
yeah, these are ugly for all of the reasons.
Yeah. It's like if you asked a cell to just do everything wrong. This is
Oh, and some more.
mm. What I love about this particular clump is that weird irregular kind of like they're all kind of different sizes, and it looks like it might have that height to it that I kind of look for with like clumps of tumors.
Mm-hmm.
Mm. Almost like black.
Yeah, and this is with the microscope in focus.
Yeah. Yeah, yeah. This is focus, adequate light, every like just, so here's a nucleus with all the same genetic information. Actually not, right? Maybe, but as this, and you just have these dramatic differences. Yeah. So listen to the stain.
And again, I think we've seen malignancy before when we're looking in some of these slides, but again, malignancy is going to look different with each patient, and it's just important to see the different ways that malignancy can present itself.
Yeah, agreed. Forgive me. I'm yawning over here.
one more batch to finish on. Oh, real. Oh, wrong way.
I vote for Lum here. Lum here. And then there's definitely been some very weird lymphs too.
Yeah.
Don't know what to say about those, but
Yeah,
yeah,
there's these, and then there's this guy here. And
yeah,
the hard part about looking at them is I don't know if they're blue because they're reactive, something's wrong with them, or if it's because they're squished between the red cells.
yeah, yeah. So I think entirely possible, because this one's kind of spooky, but the basophilia and everything, I get that could be reactive.
Mm.
The thing that's troubling about this one is this
The cleft.
there, it's pretty deep. But hard to say one way or the other.
Yeah. Okay, well, I think we've seen a good amount of these oogle malignanty looking cells, and I think that's all we have for this video. So thanks for watching.
Thank you for your time.